Hey guys, and welcome to this second video in our trigonometry series on Form 5.3 Mathematics for New South Wales. In this video we are going to look at finding unknown angles. So in the previous video we started looking at the ratios, or revising the ratios, and how they worked with finding side lengths. In this one's going to be a little bit quicker because we're just going to be looking at some unknown angles and how to find them. So let's go over a couple of little things with the unknown angles and everything to do with that. You see here we've got using the inverse. So using the inverse, what we mean is the inverse, so the opposite version really of our ratio. So for sine, we have sine to the minus 1. For cosine, we have cosine to the minus 1. And for tangent, we have tan to the minus 1. So these are our inverse versions of our ratios. That's these guys here. Okay. When we're finding an angle, this is the one that we want to use in our calculator. If I bring up my calculator real quick, you can see in this one, I don't know if you can see my little cursor. Here is our sine, the cosine, and the tan. And just above you can see in yellow writing, tan to minus 1, cosine to minus 1, sine to minus 1. And to get to those, you just need to use your second function key. And that'll be the same in pretty much every calculator. So some things around the inverse is we just type that straight in pretty much. But some things that you can already know. Oops, still in my highlighter. So sine of theta, if sine of theta equals 0.5, then theta will equal 30 degrees. So these are some things that we already know, and we'll talk a little bit later in a future video about how we know some of these things. For cos theta equals 0.5, then theta is going to be 60 degrees. Now, one of the reasons we know that is 30 and 60 add up to 90, so they are complementary. So cosine and sine, they complement each other. In fact, the co part of cosine actually stands for complement. So we've got sine and then we've got complement sine. So that's why they go together really nicely. And then we have tan. So tan is 0.5. Then theta is going to be a little bit different and a little bit more complicated. 26 degrees, 34 minutes, and that is to the nearest minute. Okay, if we're using the Cartesian plane, alright, this is one thing that is actually kind of cool. We can actually use gradient for this. So this is where this is nicely related to our linear relationships. So if I get myself a pencil and just quickly draw up a Cartesian plane just like that, chuck my y and my x on, change my colour, change the colour to purple, why not, and I chuck in a line just like this, boom, there's a line. It's pretty random. But what we do, if I change my pen colour again, is we can actually draw in a right-angled triangle just like that one to help get rise over run, right? So here's our rise, here's our run. If this is our angle in here though, this becomes opposite, and and this becomes adjacent. So we can actually link to our linear relationships and our trig, link all together very nicely with opposite and adjacent there. So that's on the Cartesian plane. So let's just make a very quick note. If the gradient equals rise over run, might just fix up my little s there. There we go. Rise over run, which is the change in height over the change in length, or the horizontal change and the vertical change, actually becomes the opposite side over the adjacent side, which is now tan theta. And we will get to see some of these link up a little bit better in a few videos into the future. So stay tuned for those developments. Let's now jump in feet first into our two examples, or our three examples rather. So find the value of theta, that's the little Greek letter, theta, in the following diagrams. So first off, we have a hypotenuse and we have an opposite side. One of the things I do highly recommend is that you get your triangle when you are doing these problems and label the sides with opposite, hypotenuse and adjacent. It'll just help you figure out which ratio you need to use. So for this one, obviously, I'm going to need to use the sine ratio. Might use the black pen again. So sine theta is opposite over hypotenuse. Sine theta is 1 over 2. And we've already seen before that that is 0.5. So what we would do is we would go theta equals sine to the minus 1 of 0.5, which is going to get us that 30 degrees. Now let's see it happen in the calculator. So I'll go shift sine, so that gets our sine to the minus 1, 0.5, close off our bracket, equals 30. So that's pretty cool that we actually can say these things straight away. So there's that first one, done and dusted. Okay, let's move on to the next one. Here we've got a hypotenuse again, but this time we've got the adjacent side. Might need to spell that a little bit better. There we go. Get my spelling correct. So here we go. Adjacent and hypotenuse, which one's that one? Well, that's going to be our cosine, or our complements sine. So cos theta is A over H. Cos theta is going to be 1.5 over 2.5. So we want to go theta equals cos to the minus 1. So inverse cos. And you can do it with the fraction. You do not have to have it as a decimal to type in. Let's see what theta actually equals. So let's bring it up. So we're going to go second function cosine, because we want the inverse of cosine. 1.5 over. Now we are using a different calculator to normal, so there's our fraction key. Need to get out of that, put in your bracket, hit equals. Now this is 53.13, 53.13. And if we want to go to one decimal place or even whole numbers, this will just be 53 degrees to a whole number. So far, we are very straightforward, and this should really only be revision for you. Let's see this as a word problem now. So this is where you're going to have to draw a diagram. So we have a long, straight mine tunnel sunk into the ground. Its final depth is 120 meters. So let's change my pencil color so I can draw this up. So I have a mine shaft. Here's our mine shaft. Straight down, poorly drawn mine shaft, but it's going to be 120 meters. Okay, so there's our mine shaft at 120 meters. The end of the tunnel is 100 meters horizontally from the ground entrance. So this is the tunnel, so this is 120 meters down. Here's the ground entrance. And this distance is 100 meters. Find the angle that the tunnel makes with the horizontal, theta, correct to the nearest minute. So we want to go down this way and find this angle. So there's theta in there. So what we're doing is we've joined up this corner here to this corner here, and we want to know what angle that makes. Okay, so we have a right angle in here, which means that we have a hypotenuse here, we have an opposite side here, and the adjacent side right there. We might even pop that in red. Okay. So first things first, we need to know which ratio we're going to use. You can see the hypotenuse doesn't have a distance on it, so we can't use sine or cosine. So we have to use tan. That is the opposite side over the adjacent side. Let's pop in what we know. We don't need tan theta just yet, but we do know the opposite side, which is 120, and we do know the adjacent side, which is 100. So we go theta equals the inverse of tan is 120 over 100. Hit the equals, and now we chuck it into our calculator. So we go second function tan to bring up our inverse of tan, 120 over 100. Get out of that bit, hit the bracket, and equals, and it's going to be 50.1944. So let me just write that in, 50.1944. So to get to the nearest minute, which is what the question is asking us, we need to click this little button here, changes it to degrees, minutes, and seconds. Now you can see over here, we've got our degrees, 50 degrees, 11 minutes, 39 seconds. So if we look at this 39 seconds, that's over halfway, isn't it? So remembering when we're rounding, if it's halfway or more, the one in front has to go up by 1. So that's over halfway because there's only 60 seconds. Over halfway, so the 11 becomes a 12. So it now becomes, so if we go 50 degrees, 11 minutes, what did we say? It was 39 seconds. Will actually be 50 degrees, 12 minutes. Okay, so that's how that's all working. hopefully this video has been informative and helpful, and good luck with your questions, and I'll see you in the next one.